Hello everyone, this is Dr. Karen's and I just want to talk to you today pretty quickly about tissue repair. So when tissues become damaged, that's an issue because our tissues are forming either a barrier or a lining or some protection or other functions, and when the tissue is damaged, you lose that function. So you want to be able to repair it. Depending on the type of tissue you are, will depend what type of repair can happen. So regeneration is complete repair. So whatever replaces the destroyed tissue is full functional, same kind of tissue that was lost. So you gain the original function, or it's restored. Versus the type of repair called fibrosis, where connective tissue replaces the destroyed tissue, no matter what that destroyed tissue was. So you lose the original function of that tissue. Different tissue types have different capacities for repair. Some can fully regenerate and some can only undergo fibrosis. And we'll talk about which ones do what in a second. First, let's talk about the steps for tissue repair. So we have a cut right here. The first step is inflammation. Inflammatory chemicals will get released, and that leads to dilation of blood vessels, bringing those inflammatory chemicals to the site of the damage. Also, the blood vessels will increase in permeability. When you get to A&P2 and learn about the immune system, you'll come back to inflammation. But these two events allow inflammatory chemicals and white blood cells to get to the site of damage to start the process of repair. And also, blood clotting will begin. Step 2, organization restores the blood supply. So organization is going to begin as that blood clot gets replaced with granulation tissue, so new capillary enriched tissue. So we're really starting to fill in the gash or the damage here. If you're talking about epithelial tissue, that is going to start to regenerate. It's a very mitotically active tissue, and we just fill it in with new epithelial cells. If you're talking about connective tissue or something else, fibroblasts will release collagen fibers to fill in the gap. If there's any debris, phagocytes will come in and take that debris away. Step 3 is regeneration and fibrosis. So we're talking about the permanent repair of this tissue. Any scab that was formed due to the blood clotting is gone. If epithelial tissue was being repaired, you get completely regenerated epithelial tissue. So you just get new epithelial cells replacing what was lost. It's as if the damage never occurred. But if fibrosis is happening, which you will see in certain connective tissues and in muscle tissue, now you see tissue here that has filled in the gap, but is not exactly the same as what was there before. And so we have now this fibrous tissue full of collagen fibers, and that's our scar. The scar is forming underneath the epithelial tissue. And if you're talking about, an area where you're looking at your skin, which is what this picture is showing you, you might have a scar, right? And the scar is not in the epithelial layer. The scar is under the epithelium in the connective tissues because connective tissues cannot fully regenerate. But these layers of epithelial tissue of your skin are transparent enough that you can see the scar through that epithelial tissue. Yeah. All right, so the tissues that can regenerate, epithelial tissues, yes. Bone tissue, yes. Areolar connective tissue, dense irregular connective tissue, and blood-forming tissue. But those that are not so great at regenerating, they can do a little bit of regenerating, but they'll also do some fibrosis, smooth muscle, and dense regular connective tissue. And then the tissues that have no regenerative capacity, they will always form a scar. Cardiac muscle and nervous tissue. And so once those cells are gone due to damage, they're gone. So it's your responsibility to kind of get a feel for which tissues regenerate well and which don't, and then make some predictions. If you have damage somewhere, what's going to happen? Can you describe that tissue repair process? Are you going to see regeneration or are you going to see fibrosis?